Hi everyone, welcome back to the Comptia Network Plus course, resolving names with the host table. The host table is really a lot like DNS, except its entries are static for each and every host and server. Within the host table you'll find a collection of hosts, names that devices reference for name resolution purposes. Even though it works in both IP version 4 and IP version 6 environments, it's unlikely you will use it these days because the host table is a very ancient relic left over from old Unix machines. But just because it's museum quality doesn't mean you won't run into it now and then, which is the main reason I'm showing it to you. You can find the host table at C, Windows, System 32, drivers, etc. Just double click the file and then choose to open the file in Notepad or another text editor. Here's the default information. It's really noting more than an explanation of how to use it and local hosts for both IP and IP version 6. Copyright 1993-2006 Microsoft Corp. This is a sample host file used by Microsoft TCP for Windows. This file contains the mappings of IP addresses to host names. Each entry should be kept on an individual line. The IP address should be placed in the first column, followed by the corresponding host name. The IP address and the host name should be separated by at least one space. Additionally, comments such as these may be inserted on individual lines or following the machine name denoted by a hash symbol. For example, 102.54.94.97 rhino.acme.com source server, 38.25.63.10 xacme.com x client hosts, 127.0.0.1 local host, :1 local host. Using the Mtr Command Pathping. Mtr or Mtr is a computer program that contains the functions of the traceroute and ping utilities in a single network diagnostic tool. It also adds round trip time and packet loss to the output. Very cool. Mtr probes routers on each route path by limiting the number of hops individual packets are allowed to traverse and listening to news of their termination. It will regularly repeat this process, usually once per second, and keep track of the response times of the hops along with the path. Mtr is great if you have Linux or Unix, but by default it's not installed on Windows devices. Third-party applications of Mtr are available to install on Windows, but Microsoft did respond with its own version of Mtr. It's called Pathping, and it provides the same functions as Mtr. Here's a look at the output and the options. C users tlaml pathping. Usage pathping -g host list -h maximum hops -I address -n -p period -q number queries -w timeout -4 -6 target name. Pathping options. Option description. -g host list uses a loose secure route along the host list. -h maximum hops specifies the maximum number of hops to search for the target. -I address uses the specified source address. -n does not resolve addresses to host names. -p period waits period milliseconds between pings. -q num queries specifies the number of queries per hop. -w timeout waits timeout milliseconds for each reply. -4 forces using IP4. -6 forces using IP version 6. Using the Nmap utility. Nmap is one of the most popular port scanning tools used today. After performing scans with certain flags set in the scan packets, security analysis and hackers can make certain assumptions based on the responses received. These flags are used to control the TCP connection process, so are present only in TCP packets. Figure 17.5 shows a TCP header with the important flags circled. Normally flags are turned on because of the normal TCP process, but hackers can craft packets to check the flags they want to check. Figure 17.5 TCP flags. Source port, destination port, sequence number, acknowledge number, reserved window size, checksum, urgent pointer options, padding. Figure 17.5 shows these flags among others: URG, urgent pointer field significant, ACK, acknowledgement field significant, PSH, push function, RST, reset the connection, SYN, synchronize sequence numbers, FIN, no more data from sender. While the application of a scan and interpretation of the response are beyond the scope of this course, security analysts and hackers alike can perform scans with these flags set in the scan packets to get responses that allow them to determine the following information: if a port is open on a device, if the port is blocked by a firewall before it gets to the device. Nmap can also be used as follows: to determine the live hosts on a network, to create a logical map of the network. Using the route command. Probably the biggest reason for manipulating the routing table on a Windows server is to create a firewall. For instance, let's say we're running an application layer firewall on a Windows server located between the demilitarized zone DMZ and the internal network. This scenario would mean the routing that's happening on the server or hosts located in the DMZ wouldn't be able to reach the internal network hosts and vice versa. To circumvent this problem, we would need to employ both static and default routing, because while Windows 10 and Windows Server versions support some routing protocols, running routing protocols on hosts and servers wouldn't be a good solution for today's networks, and Microsoft knows that. To view the routing table on a Windows device, use the route print command as shown in figure 17.6. In this output, you can see that each of the routes were added automatically when the system booted up. This is all based on the configuration of your IP stack. To see all the options available with the route command, type the route command and press enter. To add a route to your routing table, use the following syntax: route -f-p command destination mask net mask gateway metric route if interface. Using the route command options, let's start with the switches you can use. -f, using this command with any of the options like change or delete will clear the routing table for all entries that aren't host routes. Routes with the subnet mask 255.255.255.255 and the loopback network route or routes routes with a destination of 127.0.0.0 and a subnet mask of 255.0.0.0, and any multicast routes, those with the destination of 224.0.0.0 and a subnet mask of 240.0.0.0. -p, if you use this with the add command, the individual route will be added to the registry and then used to initialize the IP routing table whenever TCP IP is started. Important to remember is that by default, the routes you've statically added won't remain in the routing table the next time TCP/IP boots, and if you use -p with the print command, you'll get shown a list of the persistent routes that are stored in the registry location of key local machines system current control set services TCP/IP parameters persistent routes. Now let's take a look at how and when you use the route command. Table 17.4 shows the command options available and what they do when you are using the command with them. Table 4, route command options: add, adds a route; change, modifies an existing route; delete, deletes a route or routes; print, prints a route or routes. Here's a description of some other tasks you can accomplish via the rest of the command options. Destination. This will give you the network destination of a given route. If the host bits of the network address are set to 0, it will be depicted with the destination's IP network address, an IP address for a specific route, or a default route of 0.0.0.0. Mask, net mask. This will provide you with the net mask, often referred to as the subnet mask, that's associated with the destination network. The default destination subnet mask is 0.0.0.0, and typically you'll see 255.255.255.255 representing a host route. It's really important to remember that the destination address can't be more specific than its corresponding subnet mask. What I'm saying is that there absolutely can't be a bit set to 1 in the destination address if its equivalent bit in the subnet mask is 0. Gateway. The gateway also depends on the network address and the subnet mask, but it's even more specific and eliminates what's called next hop IP address for routes located on a local subnet. The gateway address maps directly to a particular interface. If the destination is on a remote network, the gateway IP address will direct packets to a neighboring router. Metric refers to the cost of a given route from the sending to the receiving device, and it's a value between 1 and 9999. Devices use this value to choose the best and the most efficient routes among those in its routing table. To route with the lowest value wins. This decision can also include factors like the number of hops and the speed, reliability, and available bandwidth of the path being considered, plus the various administrative aspects associated with it. Interface. This tool depends on information from the gateway address and determines the interface index for the specific interface that needs to receive the data. You can get a list of interfaces along with their relevant interfaces indexes by typing the route command. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.